Alright, in this video we are going to solve these problems involving rational expressions. We will subtract rational expressions, we will solve a system of rational equations, and we will solve a rational inequality. Every time I use this word rational, I'm just talking about a complex fraction that has a polynomial in the numerator and the denominator. Let's start with a simple problem, number 21. Let's subtract these rational expressions. Very often the first thing you want to do is look for any common factors. In this case, there's a common factor here between the 5x and the 10. So I'm going to bring that out. So if I do, the problem becomes like this. So I've still got my 15x here. But in the denominator, if I pull out the common factor of 5, that leaves behind x minus 2. So meanwhile, over here, I have 5 and I also have x minus 2. Now, when you add or subtract fractions, you want to have like denominators. So I'm going to create like denominators by multiplying by 5 right here. Now, I can make that change only if I make the same change in the numerator. So I'll multiply by 5 over 5. Now the denominators are the same. I'm not going to cancel these out. And I'm not going to cancel out these 5s either, because then I wouldn't have like denominators anymore. But once I have like denominators, I can go ahead and combine these two into one fraction by combining the numerators. So it'll wind up being 15x minus 25. Alright, so now I have 15x minus 25 over, and I just keep my like denominator of 5 times the quantity x minus 2. Be careful not to stop here. Again, there's a common factor in the numerator, and we need to bring that out. So the common factor is 5. Let me see if I can make a better 5 than that. I said the common factor is 5. That's not much better, but I don't have all day. So this is going to leave behind 3x minus 5. Okay, now meanwhile in the denominator I've got 5 and x minus 2. So what do you think is about to happen? If you said that those 5s are going to cancel out, then you are correct. Those 5s are going to cancel out, and that's why my final answer is going to be 3x minus 5 over x minus 2. Alright, so that is how you subtract rational expressions. Now, if only it were always that easy. Now we need to learn how to solve a system of rational equations like this one. Let me zoom out a bit. Now, when you solve a system of rational equations, you're going to start by setting these equal to each other and solving for x. But keep in mind, because there is a y value, in the end, not only are you going to find an x value, but you also need to find the y value. So we're going to have an ordered pair like 3, 5 or something like that. So let's go ahead and set these equal to each other. So I will have 2x over x plus 3 minus 4x over x minus 3 is equal to negative 8x minus 28 over, and I'm going to go ahead and factor this, x plus 3, x minus 3. Okay, and now you'll see why I left this extra space here, because one way of solving rational equations is to make all the denominators the same and then cancel out all the denominators. And that's the method I'm going to use. There are other methods. So I see I have x plus 3 and this has x minus 3. This has both. So this denominator is missing an x minus 3. I can add in a factor of x minus 3 as long as I put a factor of x minus 3 in the numerator as well. This one is missing x plus 3, so I'm going to put that in the numerator and denominator. This is missing nothing, so I don't need to add anything in. Okay, so once that happens, then I can just cancel out the denominators like this. Okay, so here's what I have so far. So I have 2x times x minus 3, and then minus 4x times x plus 3, and then that's equal to negative 8x minus 28. So I need to do some distributive property around here. So this is going to give me 2x squared minus 6x. And be careful to distribute negative 4, not just 4, or not just 4x. It's negative 4x. So this will be negative 4x squared and negative 12x, not positive 12. Okay, now it's time to combine some like terms. So, for example, I've got like terms here and here, so that will make negative 2x squared. Let's see, I've also got like terms here and here, so that's going to make negative 18x. So that's it for the like terms. Alright, so this is equal to negative 8x minus 28. Now, I'm noticing that I have x squared and x. Whenever I have x squared and x, I know I need to get 0 on one side, and I need to factor or use the quadratic formula. So that's what I'm going to do. Okay, it might need a little bit of extra space. So. Okay, so if I want to get 0 on one side, now I really like this x squared term to be positive. So I'm going to actually get 0 over here and move everything over to the right, just because it helps me if the leading coefficient is positive. So I am going to add 2x squared to both sides like this. Okay, I'm just putting it in the front. And I'm going to add 18x to both sides. Okay. So now over here I have 0 equals. The 2x squared has nothing to combine with, so it's just going to be 2x squared. Negative 8x and 18x is 10x, and then minus 28. Now this is probably factorable, but you know what? Let's start by factoring out the common factor of 2. So if I factor out a common factor of 2, you know what? Let's do it over here where I have a little bit more space. Alright, I'm pulling out the common factor of 2. So I've got 0 equals 2. And then that's going to leave behind x squared plus 5x minus 14. Okay, this doesn't look so tough. Alright, so I will keep that 2 for now. And then now I can easily factor this trinomial. So that's going to be x times x. 14, of course, is 2 times 7. Now, inner plus outer has to equal the middle. Alright, so I need a 5x. So if I had a negative 2 and a positive 7, that would make 5. So here's negative 2, and here is positive 7. Also, negative 2 times positive 7 gives you negative 14. So it works, people. Now, we have to keep going to find x by setting these factors equal to 0. We're going to ignore the 2 because that can't be 0, so it must be only these can equal 0. So from this factor, I'm going to get x is equal to 2. All right, and from this factor, I'm going to get x is equal to -7. Okay, now remember what I said. For this type of problem, we need not only the x values, but we also need the y values. So what we have so far are the x values. So we know we have 2 comma something, and we have -7 comma something. But we need the y values to go with them. And again, we will need the y values anytime the original problem has a y in it, like this. Okay? So how do I find those y values? Well, I'm just going to pick one of these original equations, and I'm going to substitute my x value in for the x's. Now you can do that manually, all right? I could take this 2, and say if I do this equation, I could take the 2 and substitute it in here and here. And if I solve this out, I'm going to get the y value, because y equals all of this. But if you have access to a calculator, such as the TI-30 XS Multiview, then that can make your life a lot easier. Please don't crash. So you can use the table feature, I think is the best thing to do. Alright, so I'm going to use this equation. So -8x minus 28. So fraction mode, -8x minus 28 over x squared minus 9. So x squared minus 9. Now, if I were you, I would put the calculator into ask mode, so we can do whatever we want. Flexibility. So it's waiting for us to type in x values. So we saw that we had x values of 2 and -7. So I can just type in 2, enter, and then -7, enter. So this gives me the y values that go with these x values. So let's see, 44/5 and 7/10. All right, and that is how you solve a system of rational equations. So one last problem for this video. We are going to go ahead and solve this rational inequality. Anytime you're dealing with an inequality, you're going to wind up graphing the solutions on a number line at some point. So it's just a matter of, where the function crosses the number line, where the function equals whatever value this is. So we can find one of the places where the left side of the function equals 5 by solving this equation, treating it as an equation and solving it. So if we look at this as the equation 4x minus 3 is equal to over x plus 2 is equal to 5, and we can look at this as 5 over 1, then this is one that can easily be solved by cross multiplying. So if we cross multiply along this diagonal, okay, I'm focusing on this right here, and I am going to distribute. So that's going to give me 5x plus 10. Okay. Now looking at the other diagonal, of course 1 times 4x minus 3 is just 4x minus 3. So let's go ahead and solve this. I don't see any x squared, only x's, so I'm going to get all the x's on one side and the numbers on the other side. So let's subtract 4x from both sides to get the x's together. So far that just gives me x plus 10 is equal to negative 3. And then let us subtract 10 from both sides, which gives me x is equal to negative 13. So that is going to be one of the values that will go on my number line. Let me just put it up here for a second. So I have x is equal to negative 13. Now, the other value that's going to go on the number line is any excluded value, because that's another place where, you know, if we were graphing this function, it might cross the x-axis. So the excluded value is negative 2. Okay, if I set this equal to 0, I'd get x equals negative 2. So in other words, x cannot equal negative 2. Okay, so these are the two values that we will plot on our number line as border points. So here we go. Here comes our number line. Alright, so we have negative 13 over here, and we have negative 2 over here. Okay, now excluded values are always open circles, because an open circle means that this value is excluded from the solution set. Now, the solutions are sometimes open circles and they're sometimes closed. If I have, for example, less than or equal to, then that's going to be a closed circle. If I just have less than, then that would be an open circle. Alright, so let's look back and remember. It's got that or equal to, so this will be a closed circle for this one. Okay, so now we need to find out in which zones the solutions exist. So we're going to check test values in each zone. So to the left of negative 13, I might see what is the value of the function, for example, at negative 14. Okay, and let's go ahead and talk about what I'm going to put in my calculator when I'm testing this. So, I mean, understand, I could substitute negative 14 in for x and see what's happening. But I find that it helps students to avoid certain kinds of confusion if I go ahead and just get into a habit of always getting 0 on one side when I put this in my calculator. So I'm going to move this 5 over by subtracting 5 from both sides. So this inequality is the same as 4x minus 3 over x plus 2. And if I move the 5 over, now I've got minus 5 is less than or equal to 0. So if we just always use 0, then we don't have to think about it, and we don't have to think about whether something's greater than 5 or less than 5. We can just look and see, is it positive or negative. I think it just makes it easier. So back to this. So we're going to be looking to see, is it less than or equal to 0? In other words, is it negative? So that's a lot of words I just said. Now, in between negative 13 and negative 2, we have values like negative, I could say anything in between here, but I'll say negative 10. So let's see what's happening. What's the value of the function at negative 10? Is that less than or equal to 0? And we know it won't be equal to 0 because that's what the border point is. Anyway, over here to the right, let's use 0, all right, because that's to the right of negative 2. And let's see if that is less than or equal to 0. So again, rather than do this by hand, by plugging these numbers in one at a time and seeing if it's less than or equal to 0, I'm going to use my TI-30XS multiview to help me out. And I'm going to type in this green version of the function into the table feature. Okay, so here's my table feature, and we are typing in 4x minus 3 over x plus 2, and then it was minus 5. Again, I like my calculator to be in ask mode for this type of thing. Just hit enter a few times. And let's change these x values. So the three x values we have decided to test out are negative 14, negative 10, and 0. So negative 14, negative 10, and 0. So these are the values of the function at these x values. So negative 1/12. Okay, so I've got negative 1/12. Is that less than or equal to 0? Yes, that's negative. So yes, that is less than 0. At negative 10, we had 3/8. So this is 3/8. Is that less than or equal to 0? Well, no, it is not. That is a positive number. That's greater than 0. And then what about at 0? We have negative 13 over 2. So we have negative 13 over 2. Is that less than or equal to 0? Yes, that's a negative number, so it is less than 0. Yes. So these yeses show us where the solutions are. So we have solutions over here to the left. You know, anything less than negative 13, and solutions to the right. Okay, because if you find one solution, then that means everything in this zone is a solution. And finally, let's record our answer in interval notation. So it's very easy once we have the graph. Looking at the left side of the graph, this branch goes from negative infinity to negative 13. So negative infinity to negative 13. Okay, and a square bracket means the same thing as a closed circle. It means including negative 13. And then union, since we have another part coming. And then this branch goes from negative 2 to infinity. So I've got negative 2 to infinity. This time I use a parenthesis instead of a bracket because it's an open circle. Negative 2 cannot be included as a solution because it is an excluded value. X cannot be negative 2. So this is the answer. And you know, I guess I would say the most important part here is the interval notation, which sort of just summarizes everything. Okay, so that is how you solve a rational inequality.